the retake for the slope-intercept form video. Now, slope-intercept form is a tough concept, but it's a very important one. So this video will not be the same as the last video, but it will follow the same format. So to begin, once again, we're going to talk about why we want to use slope-intercept form in the first place. And the best way to show that is to make a table like we've been doing, and to show how slow and a little bit clunky the process is. So when I make my table, once again, I want to use the numbers -2, -1, 0, 1, and 2 for the x values, and I plug them into the equation one at a time. So if I plug in -2 into my equation here, I would do -4 times -2, which is +8. +8 plus 3 is +11. If I plugged in -1, I would do -4 times -1, which is +4, plus 3 is +7. If I plugged in a 0, this would be 0 plus 3, or 3. And if you're following the pattern, you see that we are going down 4. Now, what's really nice about this, if you watched the last video, hopefully you can tell that our slope is our pattern in our table. So if you made some connections from the last few sections, hopefully you can see why we're learning this concept in the first place. Now, in order to graph this, obviously -2, +11 is way up here. So we're going to start with -1, -7, which is right here. 0, 3 is right there. 1, -1 is down here. And 2, -5 down there. And from this point, I want to draw my line. There we go. And we have our line there. But once again, from the last video, this process takes a long time. And if there's fractions or decimals involved, it gets really erratic really quickly. Therefore, we are learning a new process called slope-intercept form. Slope-intercept form is y equals mx plus b, and as a reminder, if you come and do the song with me, that is worth SPs or candy. But in this form, m stands for our slope or rate of change. Now, frequently when we talk about slope or rate of change, we do rise over run, and you'll hear that quite a bit in this video. Now, the b value, I call it the beginning value, but it is the y-intercept. And the y-intercept is where our line crosses the y-axis, which is right here. Any line that crosses the y-axis will have a 0 for the x value, and then the number b will be the second number in our ordered pair. Now, for our equation, that means that our slope is -4, or -4 over 1. Our b value is +3, or 0, +3. When I go to my graph, I want to graph my beginning value first. So I go 0, 3, and I put a point right there. Now to find the next points on our line, we are going to use our slope. So -4 over 1, which means we're going to rise -4 from here. 1, 2, 3, 4. And then we're going to go to the right 1 because we run a +1. Now that process can continue infinitely, but you can also do the opposite. So down and right is the same as up and left on our line. So I'm going to go up 4 and back 1. And now I'm going to simply create a line from our ordered pairs. This process, once you get good at it, means that you can graph a line in about 30 seconds. Obviously, we're going nice and slow right away to get comfortable with it, but it is a lot faster than the methods we've been using before. So let's try another one. A couple negatives mixed in here, so a little bit trickier. But if we're using our form y equals mx plus b, our m of our line is -3, or -3 over 1, which means we're going to rise -3 every time we run 1. Now our b value, or our y-intercept, is -2, and I like to write this as the ordered pair 0, -2. And that's all we need to graph. So we can take our b value, our beginning value, and start at 0, -2. Now we can use our slope, which is -3/1, to graph more points on our line. So if I go -3, 1, 2, 3, and I run 1, I end up right there. Now I can go up and left to follow the same pattern until I've covered my entire line. Just like before, I'm going to graph my line here. And that's it. It's all done. Now, I really want to emphasize that all we're doing is a shortcut of what we already did before. So if we wanted to make a table of values, it's going to look the same as any other table that we did before. So we have -3, 7, -2, 4, -1, +1, 0, -2, and then 1, -5. And so we have everything that we had from the original problem. We just do the process in a little bit of reverse. If you are good at slope-intercept form, graphing lines becomes incredibly fast. Let's do one more problem. This is a little bit trickier with fractions. Once again, if we were doing this problem with a table, now we'd have decimals and fractions mixed together. It gets very tricky. But if we're doing our slope-intercept form, our slope is -1/3, and our b value, or our y-intercept, is 6, or 0, +6. And now I go straight to my graph. I go 0, 6, which is right here. And now I'm going to use the slope to find the rest of the points. So I'm going to go down 1 and over 3. I'm going to go down 1 from there and over 3 more. Now I can go up and back as well. And now here is our line. Once again, if I wanted to make a table of values, it's going to look just like everything we've been doing before. We have, this point here is -3, 7. We have 0, 6. We have 3, 5. And we have 6, 4. And here's the other thing that I think my 8th graders are going to really like. If you use slope-intercept form correctly, your tables will never have decimals or fractions on them, which is a really nice thing when you're trying to then turn these into equations later. It's always easier if you have no decimals or fractions. So this was the video retake. It is perfectly fine if you still are struggling with slope-intercept form a little bit, but by all means, ask me questions if you need more help.